try to explain why propagating along the kx direction have refractive index equal to nc. Okay. We already know that the epsilon tensor, when we choose the so-called principal axis, they become diagonal form. Epsilon x 0, 0, 0, epsilon y 0, 0, 0, epsilon z. So when you consider the simple situation that wave propagate along the x direction, okay, then we have two possible direction we have two possible d vector direction, because d vector is perpendicular to the k vector. We already know that k, d, h, and in general E vector is not perpendicular to k vector, but the d vector is always perpendicular to the k vector. So if we consider the propagation direction to be the x direction, and suppose now we have d vector along the z direction. Suppose we have d equal to 0, 0, dz. Okay? Then, corresponding to this situation, only the epsilon z works, which means that we can replace the median by the original anisotropic median to replace the original anisotropic median to a new median, isotropic median, whose epsilon is just equal to epsilon. So we get refractive index equal to nc. Okay, so this nc means that the d vector is along the z direction. Propagation direction is along the x direction, and the d vector is along the z direction. Then, for this situation, E is parallel to D, because now E is now E vector is dc over epsilon z. Okay, so this is just like the wave propagates inside isotropic medium, but the isotropic medium has the permittivity equal to epsilon z. Okay, so if the wave is propagating in a medium having permittivity equal to epsilon z, then we know the refractive index is nc. Okay, so this corresponds to the polarization of d vector along the z direction. However, d vector can also choose y axis as its polarization direction. So when d vector is along the y direction, we have refract index equal to ny. Okay, so corresponding to this kx, we have n equal to nz and n equal to ny. This means the d vector is pointing along the z direction. This means the d vector is pointing along the y direction. 好，就是说你如果传播方向是 x 方向，那什么时候会得到折射率等于 nz 呢？就是 d vector 沿着 z 方向。那什么时候会得到折射率等于 ny 呢？就 d vector 沿着 y 方向，就这么简单。好，那如果是其他方向呢？其他方向都不是 normal surface 的解，啊，就是其他方向只能看成是这两种模态的叠加，啊，就 d vector 如果指向其他方向，其实就是为这两种特殊模态的叠加。但这两种特殊模态的时候，它是可以保持它的方向不变的，啊，就是它的 polarization 方向。那类似的情况也是像比如说这里哈。Suppose the propagation direction along the z direction. Then if the d vector is parallel to the x-axis, we get the refracting index nx. And when d vector is along the y direction, we get a refracting index equal to ny. But this intuitive understanding can only be applied to this very special propagation direction. For arbitrary propagation direction, you must rely on the original Fresnel's equation with normal to find the corresponding refracting distance. 啊，就是你对任意的传播方向，你还是要去解那个 n 才知道 d 在什么方向 ，e 在什么方向啊？因为我们上次有给一个公式嘛，就是说一旦你传播方向知道了，折射率知道了，你可以把一场的方向算出来，第一场的方向算出来。好，那但是在这些比较特殊的方向之后，你可以直接看出来，好，可以直接看出来。好，Let me show you one example. For an arbitrary propagation direction S, the E vector is parallel to this Sx over n squared minus nx squared, Sy over n squared minus ny squared, Sz over n squared minus nz squared. So, you see, when we consider S to be along the x direction, this means that Sx is equal to 1 and Sy Sz are 0, then what is the polarization of the E vector? I have already explained to you that when the propagation direction is along the x direction, there have two possible choices for the D vector to be their polarization direction. Okay, is the y-axis or the z-axis. Okay, and for this case, the E vector is parallel to the D vector. So this means that we have E along the y direction or along the z direction. However, when you see this result, if you substitute the Sx equal to 1 and the Sy, Sc equal to 0, you may conclude that E is along this direction, but this is incorrect. Okay. So what happened at this? What happened at this situation? You see that when propagation direction is along the x direction, then you can solve for the refractive index. One is ny, and one is nz. Yeah. Okay. So since ny, nz are different from nx, so this denominator is finite. It is not zero. So Sx is also finite. So this quantity is finite. Suppose I choose n to be my. Okay. So you see that this denominator becomes 0. 0 over 0, we don't know what is the result. I already explained to you that in the equation, Fresnel's equation of wave normal, when we consider the very special propagation direction, say along the x-axis, you cannot just naively substitute this 1, 0, 0 into this equation. You may get some nonsense result, okay? But if you consider taking the limit, then you can get correct result, okay? Now, for this situation, if I take my to be the solution of n, in fact, we get this. We get this result. Finite, infinity, 0. And this can be, we can divide the result by infinity and get 0, 1, 0. So this means that when n is equal to my, we have the polarization along the y direction. Okay. 好，你真的认真去考虑它的细节的话，会是这个样子啊，会是这样子啊。那如果你觉得这个情况很难理解、不好处理的话，那很简单，你把这个结果全部乘上 n 平方减 nx 平方 n 平方减 ny 平方 n 平方减 nz， 就是你 if you don't know how to deal with the situation just like this, you can multiply the result by n squared minus nx squared, n squared minus ny squared, n squared minus nz squared, and get the result like this. N squared minus ny squared, n squared minus nz squared, sx, n squared minus nx squared, n squared minus nz squared, as 1.这好像还是不太好。就这个情况的话，这个情况的话，你不能直接使用这个公式的就直接使用这个公式的时候，你会得到，你不知道会怎么得到什么结果但是你如果用一个趋近的方式，你会得到正确的结果但这个分析就比较困难就比较困难。好，那 So So for this very special propagation direction, if the d vector is parallel to the y-axis, you get refractive index ny, and if the d vector is parallel to the z-axis, you get the refractive index in nc. 那至于要怎么去分析这个的话，就会稍微啰嗦一点啊。但是其他的情况都可以直接算，没有问题啊。就是这几个特殊的状况会比较麻烦一点。So now we want to know the relation between the dh vector and the propagation direction. So once you know the k vector, since we have learned that Maxwell's equations for propagating in a medium without charge density and the current density. We substitute E as E0 times exponential I omega t minus k dot r. And h as h0 exponential I omega t minus k dot r. Since I have explained that when you encounter the plane wave having this exponential form, then del operation can be replaced by minus ik, and partial t operation can be replaced by I omega. So the first equation tells us that d is orthogonal to k. The second equation tells us k is orthogonal to h. And the third equation tells us that k cross E is equal to omega mu h. And the final equation tells us k cross h is minus omega d, which is minus omega epsilon e. Okay, so that's why we have this relative directions for this field. E dot k is in general not zero, and E dot d is also not zero. Okay. So the E vector has some component along the k vector and some component along the d vector. Okay. So what is the expression of D vector? According to this result, D vector can be written as minus omega k over omega cross h. However, we know that k is equal to omega over c times n times s. Okay, so this means that minus omega over c times n times s cross h. So this is minus n over c s cross h. So once you know the propagation direction s and the corresponding refracting distance, you can calculate the D vector if you know the H vector. However, what is H vector? According to this result, H vector is k over omega mu cross E. And we still can substitute the k equal to omega over c times n times s. So this gives us n over mu c s cross E. Okay? We already know how to calculate the E polarization once we know the refracting index n and the propagation direction s. Okay? So once we have solved n, we can calculate E and use the result to calculate H, and then use this result to calculate D. So finally we can find the D vector. There is another way which is simpler to find the D vector. D vector is just epsilon times E. Okay, so you can just use epsilon times E to find the D vector. So, if I substitute this result into the expression of the D vector, you get D equal to minus n over c s cross. What is H? H is this n over mu c s cross E. So here we have minus n squared over mu c squared s cross E. Okay, you can use this method to find the D vector. You can also use the direct method epsilon times E to find the D vector. So these two ways to find the D vector means that you can find the equation relating these two expressions to find the refracting index. Okay. What is this result? According to vector analysis, A cross B cross C is equal to A dot C times B minus A dot B times C. Okay? So this means that we have D equal to minus N squared over mu C squared times S dot E times S E dot S S minus S dot S equal to 1 E. Okay. So what is this? The original E vector now subject the projection of E on the S direction, which means that we now have the transverse part of the E vector, transverse with respect to the S direction. 就是说，我们现在有一个传播方向是 S， 我们把电场在传播方向上那个分量扣掉，扣掉之后就变成完全就是垂直于传播方向，就是沿着 D vector 的方向。所以这个就是 transverse 分量啊，就是沿着 D vector 方向上的那部分电场，乘上这一堆系数就会得到这个 D vector。好 ，so now we have this relation between D and E. Here, this part is the transverse part of the E vector. E transverse. Transverse 的意思就是它跟传播方向垂直。好，那我们知道现在在 anisotropic 介质里面 ，E vector 一般来说并没有跟传播方向完全垂直。好，因为刚刚看到那个方向是斜的，它把那个投影在传播方向上那个分量扣掉之后，剩下的部分是垂直。好，它有这样一个关系。So, if I now calculate the D squared, which means that I calculate the scalar product between D and T. So, I substitute the second D with this expression. So this means D dot N squared over mu C squared times E minus E dot S S. Okay. However, since D is perpendicular to S, S is in the direction of K, D dot S is equal to 0. So the second term contributes nothing. So we get N squared over mu C squared times D dot E. And remember that 1 over C squared is just mu 0 times epsilon 0. And mu 0 is equal to mu, so this becomes N squared epsilon 0 times D dot E. What is D dot E? D dot 1/2 D dot E is the electric field energy density. Okay, and in one period, the electromagnetic field transform from electric to magnetic and transform back and forth. Okay, So the total density of the electromagnetic field is equal to 1/2 d dot E plus 1/2 H dot B. And you can prove that D dot E is equal to H dot B. And this is just the D dot E. U is just D dot E. So if U is just D dot E, then this becomes the U. U is the energy density of the electromagnetic field. So you see that we can write the result like this. 1/n squared is equal to this one. 1/n squared is equal to epsilon d dot E over d squared. Epsilon d dot E. We will use this equation later to find refracting index in another way. OK， 就是说我们前面在计算这个 refracting index 的时候，我们都用 normal surface 的 equation 嘛，用 Fresnel's equation wave normal。但是我们后面呢会有一个不一样的方法，这个不一样的方法呢，用的不是 K 的资讯，用的是 D 的资讯啊 ，D 的资讯，用 D 的资讯去发现折射率啊。So we will discuss later that we can use the information provided by the D vector instead of the information provided by the K vector to find the corresponding refracting index. OK， 我们后面会用到这个。So now I go back to the discussion of the properties of these two normal modes of the waves. Okay. Given one propagation S, we get two refracting indices and also E1, E2, D1, D2, H1, H2, B1, B2. This describes the mode 1, mode number 1. This fields describe the mode number 2. Okay. 就是说，我们给定一个传播方向呢，然后去解折射率，会解出两个折射率，然后从这两个折射率呢，我们可以去推出以下东西啊。就第一个折射率对应到的电场、D 场、H 场跟 B 场的，第二个折射率对应到的 E 场、D 场、H 场跟 B 场。啊，那第一个折射率所得到这些场，它对应到一个第一号的 mode 啊，然后这个第二个折射率所对应到的是2号的 mode 啊 ，mode 所谓的 mode 的意思就是一个可以不改变形态。永远传播下去的波，啊，就是 when I say mode means that a kind of wave propagating inside this medium without altering its shape， 啊，就永远可以传播下去的这种东西就叫 mode， 啊，就叫 mode， 啊，那 所以1号就会得到1号 moment，2号就会得到2号的 moment 啊。其实平常的平面波也是一种 moment 啊，但是我们通常说 moment 的时候，你可能会听到的是，比如说坡道里面的 moment 啊，1号模，2号模态啊。那在量子力学里面，我们就说 eigenstate 啊，那1号 eigenstate，2号 eigenstate，3号 eigenstate， 它们基本上都是同样的意思，就是 eigenvector 的意思，就是某一种东西的 eigenvector。So now I want to say that there are some relations, orthogonal relations between these two modes. D1 is orthogonal to D2. D1 is orthogonal to E2, and D2 is orthogonal to D1. And S is orthogonal to D1 and D2. 其实还有了啊 ，S is orthogonal to H1 and H2。就是你给一个传播方向的时候呢，你解出2个折射率，对不对？好，然后我们前面其实这2个不用特别证明啊，这2个是刚刚画图就已经有了啊。说这2个就自动成立了啊。但是这个可能不明显啊，但是我们可以证明得出来啊。These two orthogonal relations may not look obvious, but it is easy to prove from the Fresnel's equation of wave normal. 好，我们看一下这个东西要怎么证明，我们来试一下。We know that for one propagation vector, E is parallel to this E1 parallel to Sx over n1 squared minus nx squared, Sy over n1 squared minus ny squared, Sc over n1 squared minus nz squared. Okay? And what is D2? D2 is axial tensor times E2. But axial tensor, the diagonal form, axial tensor is epsilon 0 times nx squared 0, 0, 0, ny squared 0, 0, 0, nz squared. Okay? So this means that D2 vector is parallel to nx squared Sx over n2 squared minus nx squared, ny squared S1 over n2 squared minus ny squared, nz squared Sc over n2 squared minus nz squared. Okay? So, if I calculate the scalar product为了让它变成等式的话，我把这个写成阿尔法 to make it an equality, I write this as alpha, beta are the coefficients in front of this color vector. Okay. So E1 dot D2 is equal to alpha beta times this the result is this. But is this result equal to 0?这个究竟等不等于0呢？你可以看啊，我们从前不是推过一个这样的东西吗 ？We already simplified the Fresnel's equation of wave normal and change it into another form. Look like this: nx squared sx squared over n squared minus nx squared plus ny squared sy squared n squared minus ny squared plus nz squared sz squared over n squared minus nz squared equal to 0. Okay? So if I substitute n with n1 and I also write down the similar equation for the N2.好，我写下 N1 N2 的方程式，然后我让它相减。Then I subtract the second one from the first one. You see that we have this n1 squared minus nx squared times n1 squared minus n2 squared minus nx squared, and n2 squared minus n1 squared times nx squared sx squared. Okay? This is the first term. The second term, we also get n2 squared minus n1 squared times ny squared sy squared over n1 squared minus ny squared n2 squared minus ny squared. And the third term, we get n2 squared minus n1 squared nz squared sz squared over n1 squared minus nz squared n2 squared minus nz squared equal to 0. Okay? And then we factor out this n2 minus n1 factor. We can factor out this divide the result by n2 squared minus n1 squared. So finally we get this result, and this is just what we want. Okay, so this is indeed equal to 0. And you can exchange 1 and 2 to get the other result. How about the D1 or the D2? Now you will encounter the fourth power nx, fourth power ny, fourth power nz. You just need to use this result but time different coefficient to make the result equal to fourth power of nx, ny, nz. Okay? And you can derive this orthogonal relation between D1 and D2. Okay. So this means that when we are given one propagation direction along, say, this direction, S, we get two possible k vector, k1, k2, and two possible d vector, d1, d2. And H1 H2 就 D1 跟 D2 垂直啊，但是 D6 跟 K 垂直，所以 D2 其实跟 H1 平行，然后呢 D1 跟 H2 其实是平行啊，也就是说 ，so according to this result you can very simply write down D1 平行啊 ，D1 cross H2 cross 这时候是外值 is 0 D2 cross H1 is also 0 okay好那现在还有一个东西是跟这个正交性有关的这个东西呢是跟 pointing vector 有关。When we consider pointing vector is E cross H. Suppose now the E vector consists of E1 and E2. 就说我现在呢把这两种 mode 叠加起来，构成我的电场。那 H 也是一样 ，H now is H1 plus H2. And what is S? Pointing vector. Suppose I define S1 as E1 cross H1 and S2 as E2 cross H2. Then S now in fact contains four terms. The first term is E1 cross Now it's E1 plus E2 cross H1 plus H2. So E1 cross H1 gives us S1. E2 cross H2 gives us S2. However, there are still other terms. E1 cross H2 plus E2 cross H1. These are interference terms. These are interference terms. Although, in general, interference term is not zero, but we can prove that when we consider the projection of Poynting vector along the propagation direction, the phase propagation direction, then the result is simply